Hi friends, it's Rain. I hope you're doing good. I'm better now, compared to last time. I already said on Monday I didn't feel so great, so I stayed home. Then on Tuesday I also stayed home, and still not fully recovered, but I'm doing a lot better. So yeah, Tuesday wasn't much, Monday wasn't much, and on Wednesday also not a lot. But since I had the organics exercise thing I need to go to, I obviously went there because if you skip that and you don't have a note from your doctor, you the amount of exercises for that day just get set to 0, and that's kind of inconvenient because if you get 70% of all the exercises at least marked off as completed or tried to complete, you get a bonus on your grade at the end, which I'm trying to get, hopefully. So yeah, that's why I went a bit earlier to for some food, because our Mensa and stuff and the cafeterias have really good food. So I got some food, and then afterwards I rented out a group workroom thing in the library together with my best friend. Because they had an online lecture right after an in-presence lecture, which is kind of difficult to get home in time, so we just rented out that room, and I studied papers on that second experiment, and well, yeah. Basically today I found out, so Friday I found out that it wasn't a total waste, but it was basically a waste that I did that. So yeah. Anyway, after that I went to the organics exercise, which was just boring as usual. And then on Thursday, the assistant for the first experiment was finally not sick again. Not sick anymore, because on Tuesday he messaged that he was sick, which yeah, can stay home. And so on Thursday we went in for short lab, and he wanted to do a last fun kind of reaction with us, which was a gas reaction with carbon monoxide, and something he prepared. And I got to work in the glove box, which was first, and which was really cool and also really weird with the gloves, because you got cotton gloves, and then the glove box gloves, and then latex one-use gloves inside the glove box, and I don't know, it was just weird, but it was really cool to do. So yeah, but we got into some problems. So the carbon monoxide was basically almost empty, but he said, yeah, should be enough, and then we needed some more liquid nitrogen to cool everything down properly. So we got Dura, went downstairs, had to wait for the elevator first because someone else was already transporting dangerous goods in it, and you can lock it off that it doesn't stop on any of the other floors. So we just waited there for 5 minutes, then the elevator came, we rode it all the way down, waited outside the big nitrogen tank to get some liquid nitrogen, and then the guy in front of us was like, well, it's empty. Oops. So we went back. And of course the guy in front of us got there first, so we had to wait for another dangerous good transport for the elevator, and then the elevator, instead of coming back down to the basement where we were, it first rode all the way up, then all the way down. So we were over 10 minutes just waiting for the elevator, not getting any liquid nitrogen. Yeah. I guess it happens sometimes, unavoidable. So we did the reaction, then we stole some liquid nitrogen from others in the lab, and it was supposed to turn purple, but it didn't. And then the assistant was he was a bit afraid, because he actually needed a compound we were doing that it would just die. So we added the carbon monoxide, but nothing happened. And after 5-6 minutes he just stood there and was like, okay, maybe we added a bit too little from that first reagent that we needed to get that purple thing, so I'm guessing it's just dead. Okay, we can go home now. So we went home really early. So yeah, early day off was fun. And today my partner and I went in for the second experiment, and we prepared some stuff. As I said last time, we're doing this like TTST thing, and we were really good and prepared for that first step. I have the like instructions. I can show the first step here, but to get from that first step to our product, which was that SCF, the trifluoromethyl sulfite group attached to a tetramethyl ammonium, like this, we didn't really know how to do it. We didn't really find a ton of papers on how to do it. We found a couple papers that like did it, but that group was already attached to a trimethyl silane. So we were like, okay, that could work, but how do we get that silane to work? So yeah, we spent like hours upon hours researching other papers on how to actually get that done. And then we found out. So I can draw this stuff real quick. I need a whiteboard, but I don't have a whiteboard yet. So what we found out is we have our molecule thingy, and this is the important group, and we need to get this group all the way over to make like a little salt, like this. Okay, so the problem was, in the papers we found, that you can actually get rid of this group and attach it to something else. But the rest we have here, the like organic rest, is not great, and we would actually need an aromatic rest. And so we were like, okay, let's look into it. How can we do that? And we can do that by just getting like chlorobenzene, for example, making a reaction. And then we would have like an aromatic rest next to our group that we wanted. But then we found out to get this group then over to the silane thingy, the silicon trimethyl thing, the sulfite would actually need oxygen groups to actually make it work. And so we were like, okay, do we need to oxidate it? That would be another step. It could work, yada yada yada. So we had like a ton of stuff. We had ideas, but weren't really sure if they could work out. So today we had like we had like the where we talked about it, and she was like, yeah, the way I want to do it, I don't think there is no papers out there. So we basically did all this research for nothing, because the way she wants to do it is by just adding tetramethyl ammonium fluoride. And then the host is, because since this is a salt, the fluoride would just, the negatively charged fluoride, would hopefully attack the sulfur. So like, attack the sulfur, the electron swap, and then hopefully this would just fly off. And then obviously this is negatively charged, get put at our cation, tetramethyl ammonium cation, and then we would have our product. Then we would have our product. But that's the hope. We don't know if it works. She wants to try, which is also like really cool, because that is like something, hey, this is no definitive, yes, this is gonna work, or no, this is not gonna work. We're just gonna try it. She wants to see if it works. Her boss said, yeah, that is cool, see if it works. And yeah, I think that's gonna be exciting. That was basically it. I think I should get a whiteboard, because I don't want to draw everything in ChemDraw, which is like fun, yeah, but then the explaining part is lost, because I'm just like, hey, look here, this is how it looks. So that would be cool. If you want more, like if I'm talking about reactions, if you want me to like draw them out while I'm talking about them, let me know, and I can get like a small whiteboard. So yeah, that was my week. I hope you also had a great week, and I got it done on Friday, at least the filming part of it. Gotta edit it, but I'm not gonna do it today because migraine and it's late. So yeah, hope you're having a wonderful week, and I'll see you guys next time. Bye.